The objective of this lesson is to simplify rational expressions. We're going to add in multiplying and dividing rational expressions and simplifying also. So our first step is to factor both the numerator and denominator. Then we're going to reduce common factors. And then once we've done that, we're going to simplify what remains. So this first example, if you take a look at it, you want to make sure you notice that when we do the quantity x squared minus 25 over the quantity x squared minus 8x plus 15, one very common mistake is for people to look at this rational expression and want to either reduce the x squareds or to reduce the 25 and the 15 at the end by a factor of 5. Now 5 is a factor of the 25 and the 15, but it's not a factor of the entire numerator and the entire denominator. So if it's just a factor of a term, don't reduce it. It has to be a factor of the entire numerator or the entire denominator. So notice we do not reduce the x squareds here because it is not a factor. So when we look at this, we want to go ahead and factor the numerator. X squared minus 25 factors into x minus 5, x plus 5. The denominator factors into x minus 5 and then x minus 3. If you look at this, we have an x minus 5 over an x minus 5 here. Those are factors of the entire numerator and denominator. X minus 5 over x minus 5, that's the same factor, that's equal to 1. A factor of 1 doesn't need to be listed. So when we do this, it's commonly referred to as canceling. So when we see this common factor, numerator and denominator, we reduce it or cancel it by crossing it off. And so we end up with just x plus 5 over x minus 3. That's our final answer for simplifying this. Now, the next thing to talk about is if you are asked for restrictions on this polynomial in the denominator, you have to remember that you want to do the restrictions before you reduce the common factor. So if they ask for restrictions, or sometimes they'll just talk about the domain, the restrictions for this, looking back at this denominator, x cannot equal 5 and x cannot equal 3. So we'll list that as x cannot equal 5 and x cannot equal 3 for our restrictions. Now, let's move on to multiplication, which will follow some of the same procedures. When we multiply two rational expressions together, we're going to multiply the numerators, and then we're going to also multiply the denominators. This just adds an extra step to the simplification process. We're still going to factor, we're still going to reduce, and we're still going to simplify, but you also have to bring the two fractions together by multiplying the numerators and denominators. So I'm going to go ahead and take this and factor each of my numerators and denominators. So the first step here, when I want to simplify this, is to take and factor the first numerator, that's x minus 8 times x plus 8. It's the difference of squares to factor it. The denominator doesn't factor, it's just a linear factor, binomial of just x plus 3, times the second fraction. The numerator factors into x plus 3 and x plus 6. And the denominator, I can take out a greatest common factor. Remember to look for your GCFs. So we take out an x out of this and make it x times x plus 8. Now what's nice about multiplication is all you need to do when you get it to this factored stage is extend the fraction bar to include both of them, and then you're multiplying the numerators and multiplying the denominators. I'm just going to add a parentheses around this linear binomial in the first one, just so I see it as together an entire factor. All right, now I look for common factors in my numerator and denominator. And here's an x plus 3 over x plus 3. X plus 3 over x plus 3 is equal to 1, so we can reduce it, or we could call it canceling. We see that we also have an x plus 8 and an x plus 8 in the numerator and denominator, so we reduce those two because that's equal to 1. So what I'm left with is, in the numerator, just x minus 8 times x plus 6. And in the denominator, I'm left with just an x. All the other factors have been reduced with numerator factors. Now you do have to go through the last step here. You need to simplify those two binomials multiplied together. So as I multiply them, I get x squared plus 6x minus 8x, and then minus 48, and that's all over x. And then I get this, when I simplify that, I get x squared minus 2x minus 48 over x. Now, x is a factor of the denominator, but it can't reduce with either of these x's because there's not a common factor of x in this numerator. The 48 doesn't have an x, so this is my final answer here. If you're asked for restrictions on this, remember to go back to the expression before you reduced. So the restrictions on this would be that x cannot equal -3 from this first one, x cannot equal 0 from the next factor, and then x cannot equal -8 from this factor here. All right, now let's talk about division. So we've done simplifying, we've done multiplication. Division just adds one extra step. We have to remember that division is multiplying by the reciprocal, and so we're going to take and multiply by the reciprocal of the second fraction. So I'm going to start by doing that step. I'm going to take my first fraction, x squared plus 10x plus 9, that quantity, over 7x, and I'm going to multiply and just flip the second one. I'm going to make it 7x squared plus 21x minus 28 over x squared plus 5x plus 4. Now once I've got that, I'm going to go ahead and factor each of these polynomials. So this first one here, that's going to factor into x plus 9, x plus 1, all over 7x. And this one up here, I'm going to factor out a common factor of 7. Take out the greatest common factor first, so x squared plus 3x minus 4, all over, and factor this denominator. I'm going to get x plus 1, x plus 4. Now let's go ahead and I still need to factor this one totally, so I'm going to list it one more time. X plus 9, that quantity times x plus 1, all over 7x times 7 times this numerator factored into two binomials. I'm going to have x and x. I'm going to have a plus 4 and a minus 1. 4 times -1 gives me the -4. 4 plus -1 gives me the 3. Now in the denominator I get x plus 1 and x plus 4. Now I'm looking, now that it's multiplication, I can extend the fraction bar, make it multiplication, numerator and denominator, so straight across numerator, straight across denominator. Now I look for common factors in the numerator and denominator. Well, here's an x plus 1 and an x plus 1, so I can reduce those out as a factor of 1. I see an x plus 4 and an x plus 4. Those reduce out as a common factor of 1. So what I'm left with then is x plus 9 times x minus 1. And before I go further, oh, I still have a 7 there. Notice that that 7 is a factor. It's 7 times x times the rest of this in the numerator and denominator. So I'm going to have just left over an x in the denominator. So now when I multiply that out to simplify, I'm going to get x squared plus 8x minus 9 all over x is what I have left over. So when we're doing simplifying rational expressions, the first thing to do is follow your 3 steps: factor, reduce, and simplify. And then remember, when you do multiplication, it's just like extending, where you multiply the numerators and denominators. Division is just where you multiply by the reciprocal of the second fraction, then go ahead and treat it like a multiplication problem, simplify, and then come up with your final answer. And if you are asked for restrictions on the problem, you look at the factor denominators before you reduce.